will come from completing the square and things that come along with completing the square, like vertical, horizontal shift, orientation, and family of graphs. So let's go ahead and click on this. I'm not going to go over that. Okay, this is one we did the other day. This is a test question. And you're going to start with y is equal to ax squared plus bx plus c. Somebody tell me what that is. Y is equal to ax squared plus bx plus c. What is that? Quadratic form. Not the quadratic formula, but that's quadratic form. So when you see this question, you're going to start with the quadratic form, and you're going to start with this guy. Okay, so phase one, or part one, you're going to use this guy. Plug and chug and solve for C. So plug and chug. I want you to solve for C. You should be able to do that, Jay.
We cannot see what you said.
Well, I sent it. I see it at the Easley campus, so y'all must have not hit accept.
We just see the cover of the textbook.
Okay, so that means it froze. All right, I'll send it again. Let me ask you this, Pendleton. When you walked in, did you have to pull Skype up, or was it already up?
It was up, but I closed it out.
Okay, good. All right, I sent it again. Is it coming?
No.
Okay, I'm going to X out. I'm going to take you out and bring you back in, okay?
All right.
Declined your invitation. Okay, be that way then.
They're all halfway out the door now.
Yeah. All right, now it should ask you to accept.
Yeah, we got it.
Okay. All right, so plug in 0 and 5. So that's going to be 5 is equal to A times 0 squared plus B times 0 plus C. And what happens to the first two terms?
0.
And that leaves you with B or C equal to 5. Everybody with me? So let's go over here. And yes, you know that the y-intercept is 5 from looking at it, but I'm just, C is equal to 5. So that's part one. Now you're going to take C, and you're going to take these two. This is part 2, and part 2, and you're going to plug and chug. So I'm going to take, here's part 2. This is part 1. Part 2. I'm going to take my first one and I'm going to plug and chug. So that's going to be y is equal to ax squared plus bx plus c. And y, in this case, is going to be 13 is equal to A, and there's 4, it's going to go in, A 4 squared plus B times 4 plus 5. Work that one out. And then Y is equal to AX squared plus BX plus C, and that's going to be 25 is equal to A times negative 2 squared plus B times negative 2 plus 5. Okay, now finish those. And you're going to have two equations, two unknowns, and we're going to use solving systems of what? So I'm going to use elimination. But you should have something A plus something B is equal to a number. And then you'll have another something A plus something B is equal to a number. And you're going to use elimination and find A and B. So go ahead and do that. Jake, you think you can handle that?
Of course.
Pendleton, you got any questions?
Sure.
So make sure everybody prays that Wisconsin beats the crap out of Ohio State.
I hope so, man.
It's going to take Ohio State and it's going to take Wisconsin and Penn State both to get Ohio State knocked out of the top 5.
Ain't Penn State 6?
Yep.
So that should bump them at least a spot.
Listen, I'd love to see Penn State in the top 5 versus Ohio State because I don't think Ohio State's that good.
I mean, they're kind of almost the same as Clemson. They really don't play nobody.
Exactly. They play in the Big Ten, which is arguably probably the second worst conference in the whole college football system.
Which one's the worst?
Don't you say it.
I'm not going to say it. All Cupcake League. All cupcakes. I mean, honestly, give me a team that's worth anything besides Clemson in the ACC.
Miami.
Wake Forest.
Oh, come on. Miami? Really? Miami is what, 3-3 or 4-3? I mean, yeah, you got some 4-3 teams, but how many? Okay, let me say this. Besides Clemson,
There's decent teams.
How many ACC teams are in the top 10?
One.
Wake Forest ain't
In the
bad,
top
though.
10. Now, is it going to stay that way forever? No, I don't think so. I think eventually the ACC will do so. Everything's cyclic, everything. I think eventually the ACC is going to come back around. But right now, you can't say the ACC is the best conference in the college football system.
Dawn's going to be pretty good one. UNC was really good.
Yeah. UNC was good, Florida State was good, Virginia was good, and Clemson was good.
Miami.
And Miami was good. Now that's when it was rocking and rolling because you got your cupcakes. I mean, Boston College and Duke and Wake Forest and I mean, but now Duke is the top of the. Isn't Duke the top of the ACC East or whatever?
Hey, Duke is Alabama's best win.
What?
Duke is Alabama's best win.
Yeah, Alabama ain't played anybody. Alabama's going to have their bowl full the next 2 weeks. Alabama's going to play LSU
Games now?
and Auburn.
Okay, wow.
Oh, yeah.
Yeah, that's
Okay, here we go. So 13 is equal to 16A plus 4B plus 5. And that 5 comes across the river, minus 5. And 13 minus 5 is 8. Somebody check me. 16A plus 4B.
Yep.
That's one equation. And now 25 is equal to 4A minus 2B plus 5. And that 5 comes across the river. 20 is equal to 4A minus 2 what?
B.
And now you have your two equations to use for elimination. 8, and this is technically part 3. So you got 8 is equal to 16a plus 4b, and then 20 is equal to 4a minus 2b, and which one am I going to get rid of?
The B's.
I'm going to get rid of the b's, so I'm going to multiply bottom by 2. Do you have a question?
Flush.
Thank you.
Okay, so that's going to give me 40 equals 8a minus 4b. 2 times 20 is 40. 2 times 4 is 8. 2 times negative 2 is negative 4. So what's 40 plus 8?
48.
48.
I can't get nothing past y'all. And what's 16 plus 8?
24.
So A is equal to what?
2.
And now you can back substitute, and I'll go call this 4. Back substitute. So I'm just going to pick one of my, check that, the first one, 20 is equal to 4 times 2 minus 2b. Minus, dadgum, y'all sick. Dadgum, 12 is equal to negative 2b. Divide by negative 2. And b is equal to negative what? 6? Now you've got a, b, and c. So your equation, write this down, should be y, or f of x, is equal to, where's b? 2x squared minus 6x plus 5. And that is your answer. Now, yes, this is a test question. No, I'm not going to put 5 or 6 on it, because why? There's 4 or 5 parts. So I'll probably put one of these on the test, if not 2.
So when you got A, you went back and plugged in one of those X and Y.
I plugged in A to the 2 on the bottom, either one. Now, why did I pick the 20? Smaller what? Numbers. The 4 and the 2 is smaller than the 16 and the 4.
Oh, you took
Yeah, one of those down there, yeah.
Okay.
Question, Pendleton, easily?
Hey, when is the test? Do you have a date for it? I don't see it on Pearson, so that's why I asked.
All last class. Huh? Something about an all last class.
I can't remember. It was
Not a
long.
date, but like having a test.
When was it?
Like 2. I think he said he was talking about having one like 2 weeks ago.
Oh.
Outline when we go finish the. Now, do y'all want a chapter 3 and a chapter 4 test? Y'all want 2 tests or 1 test?
Dude.
I'll go for 2.
Okay, what about Pendleton?
One.
Middle one.
You want 1
I'm
test?
from Easley and I just want one.
Okay, Easley wants 1, Pendleton wants 1. Anderson, 1 or 2?
2.
Oh, come on.
One time.
2.
Well, I'll figure out what we're going to do later, but right now let's just go to the next problem. I'm going to erase this so you can see if we got it right. All right, see what we got. Is that what we got? I think that's what we got. So that's how you do that one. So make sure you can do that one. Now, they may give you one like this, but I'm going to start to show you how to do. So let's go ahead and do that. Let's see. Go ahead and write this down. Go ahead and write this one down. The table shows the dollar value of projected dollar value, blah, 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 blah. U.S. mobile internet advertising market for the years 2006 to 2012. I feel like I've already done this problem. Well, that's all right. We'll do it again. So write down those years, and then we're going to go into the spreadsheet, and we're going to do a trend line, and then we're going to do it in the calculator. And I want you to be able to find a trend line with the calculator and the spreadsheet. That's what I'm going to test you on with these type questions right here. So you got that, Jake? I don't want you to have to do this one by hand.
Great. Good deal.
Jake's watching porn. So write those down so I can ask you what they are when I type it into the Excel spreadsheet, because I can't pull up both. Well, what I could do, I could pull up the Excel spreadsheet. I'm going to try something here, guys. I did that last time, I believe. Okay, there we go. I'm going to pull this. Let's see. I'm going to pull this. Okay. Hold on, guys. I'm doing something right now.
Take your time.
There we go. Yeah, I'm sure y'all really, there we go. Okay, now I can make this. I'm moving some stuff to my screens over here so I can try to do everything, not be a T-Rex. All right, here we go. And this is for people that like to use the Excel spreadsheet. If you don't, then use your calculator, okay? So I'm going to put the year in right here, and I'm going to put the billions of dollars. I'm going to put that right there. So 6, 7, 8, 9, 10, 11, and 12. And then right here, we're going to plug in 0.045, 0.114, 0.273, 0.409, 0.545, 0.791. Y'all make sure I'm not making a mistake. 1.023. And now we're going to highlight these two. Go up to Insert. Go to Dot Plot. And there's your dot plot. I think I did this at the end of class last time. And hit Trend Line. You right click on your dots, hit Trend Line. It's not linear. I would say it's polynomial, because that's what we're studying. So, and go down to the bottom and hit Display Equation and Display R. I'll tell you why I said R in just a second. And I'm going to highlight that, and we're going to change it to where y'all can see it. And it didn't change. And there, write down that equation. Now this is what I want you to be able to do when you're given a graph or a table on the test. Everybody got that? So if you're given a couple of points like we did a while ago, I want you to do that by hand. Okay? And then I want you to do this by using the Excel spreadsheet or the what? The calculator. So now I'm going to go to the calculator. Of course, I know some of y'all probably can twirl it around on your finger like a basketball, but I'm going to show you some of you that don't know how to use a calculator, which is not a bad thing. Go in and you go to Stat and go to Edit and type in 6, 7, 8, 9, 10, 11, 12, and then go over to the next column and type in 0.045, 0.114, 0.273, 0.409, 0.545, 0.791, and 1.023. Everybody with me?
Yes, sir.
Now, before we do anything else, I want everybody to go to Catalog, second 0, and go to Diagnostic, second 0. Go down to Diagnostic, and this is especially for some of you that have older calculators. Go to Diagnostic and click on Diagnostic on, enter, and enter. Now what that does is that gives you more information on your linear regression.
Wait, where did you see that?
Second
Second.
0,
Okay.
and go to Diagnostic on, go down, scroll down until you get to Diagnostic on, hit enter, enter, and when it says done, you're done. You have to do that whenever you turn it on, unless your calculator keeps this calculator on the screen, it doesn't keep a memory.
Yeah, mine's probably that old.
All right, so now hit that, and if you want to draw it, we'll draw it in just a second, but go to Calculate, and go to Linear Regression, number 4, and type in second 1, comma, second 2, which is L1 and L2. That's your columns, and hit enter. And there is your information. Oh, I did linear. I'm sorry. That's not right. I did linear. We're doing poly. Go to Stat, Calculate, go down to Quadratic. Quadratic regression. Type in second 1, comma, second 2. Enter, and that should be your answer. Write that information down. Now, somebody is going to ask, well, what's R squared? I'm going to write it down for you. R squared is what we call the correlation coefficient. And you might need to know this for any standardized test. Correlation, I don't know how to spell correlation. Correlation coefficient. The correlation coefficient is what we call R. The correlation coefficient goes between -1 to 1. -1 being a strong negative correlation, to 1 being a positive, strong positive correlation. So take the square root, somebody take the square root of 0.9974 and tell me what you get. It's going to be very 99998. What is it?
0.9986.
9986, whatever.
Yeah.
That is a very strong correlation coefficient. So in other words, this regression line is fitting these points very well. So there is a very strong positive correlation here. So make sure you can do it on a calculator or you can do it on a spreadsheet, because I can give you a couple of these on the test. So make sure you can do it, okay? Jake, you still with me?
Yes, sir.
Y'all for quiet. You're not asking any questions. Of course, I'm used to that with Pendleton. Pendleton, are y'all still asleep or awake or what?
Kind of half and half.
Okay. Yeah, you hadn't figured it out yet? What'd he say? All right, next one. And then they'll see, oh, how do you graph on a calculator? Let me go show you that, because some people might not know. pull up your calculator, go to y is equal, second y is equal, turn on click on number 1, and if you want a dot plot, hit on, and then go down and do a dot plot, which is that first one, hit enter, and it defaults to L1 and L2, and then hit graph. Now, hit zoom, and there should be a zoom stat. Zoom 9. And there is and now you can go back in, and somebody give me the formula, somebody give me the equation.
Y equals 0.014.
Just say point, don't say 0 point, say point.
0.019
149 x squared.
minus 0.105x.
Hold on a second. I don't know what the hell I'm doing. I'm using the keyboard. You can't use the keyboard with this dadgum. Hold on. 149. I have to use x, and then I have to do, sorry, and then what?
Minus 0.105.
0.105x.
Plus 0.137.
0.1 what?
137.3.
And graph that on your handy dandy dot plot, and that's what it looks like.
What did you click on the second zoom part?
Second zoom 9, just hit 9, stat.
9.
And that's how you can do everything on your Google, not your Google, but your Excel spreadsheet or your calculator. And I don't know, some of y'all may not have known that, but some of y'all come from the calculator drill team in high school, so I don't know who's on what. Did you know how to do that, Jake?
Of course, I was there when it was made.
Yeah, I figured. You probably invented the TI, didn't you?
I did.
Okay. Just wanted to
I've
make
got
sure.
stacks of money in my bank account from that.
Why are you?
My ex-mother-in-law created the first computer.
Yep, I was there when she did that too.
Yeah, she probably created the first space shuttle. Okay, so there's that. They're showing you how to do that. If you want to find something intersection, here's x is equal to 17 or y is equal to 3. You type in y is equal to 3 and you can put in anything at that point. So I'm not going to go over that. There's another one, and it gives you more points. I think you should be able to type that one. Go ahead and write this one down and use that one as a second example, and you need to do that one on your Excel spreadsheet or your calculator, so that way you'll have 2 in your notes. So you've got 3 problems in your notes. You've got 1 by hand, you've got 2 I just did, and then this is the 3rd one that you need to work on by yourself.
Are they judging this as the years after 2000?
Yes.
All right.
So
8, 9, 10, 11, 12 to 20. So, and that will be 3 problems that you have that's going to be on your test, or 2 that's going to be on your test, but you have 3 examples.
wait, you want us to just go straight to the calculator?
You can do it, do it on your own. I'm not going to do it. I'm going to just give you another minute or 2 to copy this down, and then we're going to move on. In probability or algebra, when I let you use the calculator, that's for y'all to do it. Calculator and spreadsheet, you work on that as much as you want to at home. That's called homework, raising the bar. The more you do, the better you are. Not lowering the bar, being lazy and not doing anything, and then crying and whining when Jake is working at McDonald's.
Would you like fries with that?
Yeah, would you like fries with that?
I've got that down pretty good.
The best scene in any movie has got to be the Bah, B-A-H, the Bah scene from Good Will Hunting. Y'all ever seen that movie?
I am not.
Really? Pendleton. Has nobody up there at Pendleton seen Good Will Hunting?
I've stared at it. I've seen parts of it.
It is a very good movie. Very good.
When was it made?
I don't know.
90s.
What's that got to do with it?
I probably haven't seen it if it's old.
Oh, so y'all just don't. Oh, y'all don't. Okay, I'm sorry.
Some of the old
If a movie's up more than 10 years old, you don't watch it. Okay.
Animal House is like an old movie, and it's one of the best
Animal
movies.
House.
Like the Rocky series.
I tell you what, our future in the U.S. is doomed.
Like
Our future is
some
doomed.
of them.
We don't watch old movies.
I've
You
never heard of
know,
that.
forget old songs. We don't even watch old movies, so you're not going to listen to old songs.
Like it.
Hey, I love old music.
Be quiet, Jake.
Hey, listen to Jake.
Jake listens to the Bengals.
I'm
That's what he
actually
listens to.
Taylor
All right,
Swift
so
fan.
that's what it looks like. Go ahead and write down that so you'll at least know if you're doing it right. Write down that equation so you can check your math. I say Jake's probably a headbanger.
No.
He may be one of those emos though. He may be one of those that gets all emotional. That was most of the 90s and 2000 music, emo music. All right, y'all got that written down? Next. And you can see that's what it looks like. I'm not going to... But make sure you can do those.
Hey, have you guys
And-
seen that new Zombieland yet?
No, I don't do... I think zombies are stupid. I'm sorry. I just don't understand. I've tried to watch zombie movies, and I just
No,
don't
this
understand
ain't
them.
like a zombie.
No, it's not like a zombie movie. It's more of a comedy.
Yeah,
It just
it's
has
hilarious.
zombies in it. It's hilarious. It's got Woody Harrelson. That dude's funny.
Oh, I don't.
You don't like Woody Harrelson?
Not
What's
in
your
the least.
favorite comedy?
I like Buzz Lightyear.
I'm trying to get to another problem. Hold on.
He makes fun of Toy Story one more time.
Okay. That's it. So let's go to the next section. So out of that section, what should you be able to do? You should be able to do it by hand. You should be able to put it in your graphing calculator, and you should be able to put it in the Excel spreadsheet, vice versa. Okay?
Yes, sir.
Probably one question on each. 4.1. This is where we're doing our vertical and horizontal shift. This would be like, it's not even a review for you. You should know how to do this without even looking at it. Why? Because we spent so much time on it in Unit 1. What's the difference between these two?
Miners.
Do we have a vertical or a horizontal shift? Vertical. Yes, we have a vertical shift.
Tackle.
Need two colors here. Your f of x, this is your parent graph. Remember me giving you those 8 graphs? Parent graph. This is your parent graph. So you draw the parent graph. It looks something like this. There's the parent graph. This is the graph that you're comparing it to. And this is g of x is equal to x plus 0 squared plus 2. Remember, I told you, if the number is attached to the x, it is a horizontal shift. If it's not attached to the x, it is a what? Vertical shift. So this is your vertical shift. So that means that we're going to take this parent graph and move up 2 and redraw it. And that is what you're going to be doing in this section. And like I said, most of you should be saying, oh God, that's easy. Because we spent a lot of time doing it in Unit 1 with completing the square, or Unit 2 with completing the square. And there is your graph. Now, I'm not going to ask you to do this. All I'm going to ask you to do is sketch it. Okay, that's a -2, so it's going to be, that's a vertical shift. Again, this should be simple. We've already covered this. X plus H, that's the horizontal shift. K is the vertical shift. All right, this is your horizontal shift. What is significant about the horizontal shift? It's always the what? What is the vertex? It's always the what?
Or.
It's always the opposite, right?
Yep.
Okay, thank you for the interaction.
Say goodbye.
So this number is attached to the X. So that means this is not a vertical shift, it's a horizontal shift of 2 to the what? Left. Remember, when you get your vertex, f of x is equal to x plus 2 quantity squared minus 6. What I tell you to do, this is what? The opposite, and you bring this down. Or, if this is on the other side, you take the opposite of both. Remember me telling you that? Okay, so now, this guy has a horizontal shift of 2 to the left. So 1, 2, and it's going to be like that. Again, I'm not going to ask you to plot any points. I'm just going to ask you to find the graph. And there'll be a multiple choice graph. So it's not like you've got to do much. You just got to pick the graph that best fits. There's two examples right there of test questions. -2 would be to the what?
Right.
To the right. So everybody, like I said, everybody should be saying this is real simple.
Yeah, it's simple.
Thank you. All right, do this one. I want you to draw the parent graph, and then I want you to draw the second part in red or a different color. I feel like I'm insulting y'all's intelligence here, but I don't.
I'm just trying to get a reminder.
We've spent so much time on this that y'all should all be like, this is simple. If we could ever get the Marlboro Club to quit coughing, y'all got to stay off the Marlboro Reds. Them things will kill
Sorry,
you.
man. They're addictive.
So what does this mean?
Shift to the left.
-2. What does this mean? You just bring that down. So there's our vertex. -2 and +1. So on the test, if I give you 4 graphs to pick, you would pick the one that's in the second quadrant. That's a test question.
Awesome. Makes so much sense.
All right. Now this one is going to be a little bit bigger, but just tell me what the vertex is. Positive 55 and 4,500. But what does this tell you? It's opening what? Concave down or opening downward. So positive 55 and positive 44, and then it's going to be what? Question, great, complaint. It's easy,
No, sir.
isn't it?
Yes, sir.
Hopefully y'all are saying it's easy. And then, of course, you would put that in a calculator to check it. And there's the parent graph of negative x, and then this is the vertical and the horizontal shift.
Calculator.
Yeah, y is equal to negative, blah, 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 blah. Next, this one, they're asking you to find the vertex. I'm not going to spend a lot of time on that one. Here is a power function. Now, what does the power functions look like? Well, I showed you. It looks like that. But go ahead and graph this one. Let me find my handy dandy calculator. I'll pull up my handy dandy calculator. And we're going to type in y is equal to 4.947, and then x, and then caret symbol, and then 0.495. Now you're going to have to turn your stat plot off. So go back to second stat plot and turn the first one off. If you don't turn it off, it's not going to graph right. And now hit graph. And of course, it's still in that graph stat mode. So you got to hit zoom and either fit or standard. Okay, I don't know if that was fit or standard. I'm going to go ahead and hit. Let me hit, I think that's, let's do standard. There you go. And you see that it's going up and over to the right. And then it tells you to find the function after 2010. So you can actually go to window, I think table, sorry, second graph. Now there's some, of course you're going to have to wait, or you can type in second table set and ask for the independent variable. And now hit table and type in 2010, which would be after what? Be 10 years, right? So type in 10, and there's your answer. Who's tapping on the table? Please stop.
It could be from like Townsend or Anderson. No, it's not Anderson.
That was ours, but I don't know how that did that. That ain't no joke. Nobody was tapping on that.
Gotta go.
I promise.
Okay.
I can't see how you heard
It must be the spirit that is in your room.
Jake sounds.
Ask dude, man. I promise. Because it started doing it, and I just looked at him, and I was like, I promise, no joke.
Next question. And I'm just going to move on because I really don't. There's the one. Now they did a plus 10, which means a horizontal shift of 10 to the what? So where would that be? That would be over here in the what quadrant? That'd be over here in the second quadrant. Why am I not showing it? Because we want to deal with the what? We want to deal with the first quadrant. So, you know, even if you added a horizontal shift of negative, what it would do, it would just make it project over here, and that's not a big deal. But what they're doing is they're telling you after 2010, they're telling you to move it 10 places to the right plus 10, which means 10 places to the left. But 10 years after would be 10 places to the left. So that's what they're telling you. Not a big deal. The only thing I want you to do in 4.1 is to be able to move a graph, sketch a graph, or find a graph based on what you're given. Okay, compare the graphs of k is equal, so you type that in, y is equal to kx squared, but I don't understand what y is equal to x squared. It's going to be a parabola. Oh, okay, I see what they're doing. What does the orientation do? we talked about this. The orientation, if you have A, and y'all remind me, we talked about it, y or f of x is equal to A times x plus h, quantity squared, plus k. What does A tell you? It tells you what? Orientation. If it is compressed along whatever axis, if it's compressed along one axis, that means it's what on the other axis? It's stretched on the other axis. We talked about this, right? And then if it's negative, that means it's going in the opposite direction. Okay? What if A is between 0 and 1? If A is between 0 and 1, it's wide, wider than the parent graph. If A is greater than 1, it's what than the regular graph? More narrow. We talked about that, right? Yes or no? I think we have. So here is y is equal to x squared. Y is equal to x squared. Everybody with me? Now what does this do? We'll do that in red. Again, I don't want you to plot it. I just want you to, what is 3? What does 3 tell us? 3 is greater than what?
1.
So it's going to be narrower. What is 1/3?
Wider.
It's going to be wider. They're going to give us an example here in just a minute, and it's going to have a horizontal shift. It's going to have a vertical shift, and it's going to have an orientation factor. I think this is a homework question. They do y is equal, and then they make you do these two right here, and it's a complicated graph. I don't use it as a test question because I just like to give A, B, C, and D for test questions. So that one's narrower, and this one is what? Wider. Everything is compared to what? Your parent graphs that I gave you, those 8 or 9 graphs. Everything goes there. And that's what I'm telling you right there, wider and narrower. I wish they just put normal. This is a cubic function. No, see, they shouldn't do that because you haven't even learned that yet. This function right here is what we call a rational function. And you may have this, look in your parent graphs. Okay, f of x. Somebody tell me if y'all got this one in your parent graphs. 1/x. You should have it out. Parent graphs. Go look at your parent graphs. Do you have 1/x in your parent graphs?
Yes.
Yes.
Okay, and that function looks like this. Half a volcano. So you know that this function that they gave you in the previous slide, let's go back to the previous slide, is going to look like this. Because it's irrational. But it's got a vertical shift of what? Down 1,200. Let me rewrite this. Can I rewrite this as this?
Yes, do it all.
1/20,000 times 1/p minus 1,200. Can I rewrite that like that?
Yeah.
What is 1/20,000? Is that above 1 or below 1? It's above 1. So you know this one is going to be compressed along the x-axis and stretched along the what? The y-axis. Because that 120 is way above 1. This 1/p tells you it looks like this. This tells you that it's being compressed along the x-axis. And what does the balloon do if you push on the sides? What does it do?
It gets bigger.
It stretches along the x-axis. That's what that tells us. And then this is our vertical shift of 1,200 down.
So would that bring that top one
It would bring it down, yeah. But it's just basically going to change hold on a second. It's basically going to change, yeah, there it is right there. They don't show it because 120,000 is so big, they just left it 1 over P. So down what? 1,200 units. Because they said that they made this equal to, I think they just took a 0 off or 2 zeros and just down 1,200. Oh yeah, that's 1,200 right there. All right, and they're just looking at the first quadrant because this is a business type question. So that's why they're doing from 0 to 100. Determine the cost of obtaining drinking water. It contains 5% impurities. We substitute 5 for P, and that'll give us $23,000 to obtain drinking water that contains 5% impurities. You need a 0 water. I got a 0 water. I got one of those big basin things.
Those things are nasty.
Why are they nasty? It makes the water taste better unless you like drinking crap.
Oh, I thought you were talking about that smart water, that carbonated water.
No, I don't drink water in a bottle. I think that's kind of, I think that's kind of weird.
I tried it. It tastes like baking soda.
Yeah,
does.
Do you like well water?
Yes.
that's what I was raised on. Well water.
That bubbly.
Hey, well
Yeah, I
water's
tried to
fine.
drink smart water. It made my head hurt.
I was raised on lake water.
That's a joke.
Makes sense.
I thought it was funny.
Ah, yeah. Okay, write this down. Even function. Now, all of this can be watched on my 110 videos also, because we just covered all the stuff. F of negative x is equal to f of x. That's called an even function. An even function means that it's symmetric around the y-axis. Write that down. Even function means that it's symmetric around the y-axis. Example, f of x is equal to x squared. That is symmetric around the y-axis. And then an odd function is symmetric around the origin. And it's not going to show you that. Yeah, good. All right, so I'm going to draw you an example here. Because basically, if you just look at the example, you understand what I'm talking about. F of x is equal to x squared. That is symmetric around the what? Because this side looks like what? That side. So it's symmetrical around the y-axis. And to test that, if you plug in a negative x into this function, what are you going to get? You get the same one thing. Now, why is that? Because whenever you square something, it's always going to be positive. So that's the principle behind it. So that's why you're always going to get a symmetrical graph when you have a even function. An odd function, however, of your family of graphs, what does odd functions look like? It's symmetrical around the origin. So this side looks like that side. Now, what do you have to do there? Well, let's do an example. F of x is equal to x cubed. Now, plug in negative x. Negative x raised to the third power is equal to negative what? X cubed. What happens if I put a negative in front of f of x? What do I get? X cubed. What do I get if I put a negative in front of f of x? I get what? Negative x cubed. So do they equal each other? Yes. Basically, the property behind it is if you raise a negative to an odd power, what are you going to get? you're going to get a negative. And that's why it's symmetrical around the origin. Because if you plugged in a negative number and got a positive, then it would be symmetrical around the y-axis. So if you really sit there and think about it, it makes a lot of sense. Put a flag on that because you're going to see that on the test, maybe one question. Maybe I shouldn't tell y'all what's going to be on the test.
I think you should.
No. All right, look at x squared on your 1 over x squared. If 1 over x looks like a half a volcano, if 1 over x looks like half a volcano, then what do you think 1 over x squared is going to look like? It's going to look like a full volcano. So what would negative 1 over x squared look like? Not a volcano, but a vortex. It would be like that. For some of you that's not nerdy enough to know what a vortex is, redneck, application of a vortex would be a funnel, like funnel in beer. Jake?
Oh.
Okay, that's a vortex. All right, question on that. So, we've got, graph that on your calculator now. Y is equal to 2x squared over x squared plus 1. Y is equal to 2x squared over x squared plus 1. And that 2 tells us that it's going to be compressed along the x-axis and stretched along the what? The y-axis. So it's going to be a little bit skinnier than a regular volcano function. And make sure you can graph this on your calculator because I'm not going to ask you to graph it by hand. So take your handy dandy calculator. Take your handy dandy calculator and say y is equal to, and I'm going to put, since my calculator does not, it's not a little GOD, I'm going to say 2x squared, close parentheses, divided by, parentheses, x squared plus 1. Close parentheses. And graph. And there, and see, it does it a little bit different because it's 2x squared over, you see the volcano, but in this case, it's going down a little bit, and you need to zoom in maybe, because you got x squared over x squared, and you also got, I'm fixing to show you something else. You've got a vertical and a horizontal, like that. X squared plus x squared, your horizontal asymptote is 1, and x squared plus 1 minus 1, x squared cannot equal a negative number. So that's why you don't have a vertical asymptote. So that's what it looks like. So make sure you can actually do this problem. And if you plug the negative x in, look here. You plug the negative x in, what do you get? Do you get the same thing? Yes. So it's symmetrical around the what? The y-axis. Question on that one. So make sure, this is what you need to be able to do with this problem. Put it in a calculator and then tell me if it's symmetrical around the origin or if it's symmetrical around the y-axis. It's symmetrical around the y-axis. And nobody's asking questions, so I guess I'm just assuming that everybody knows what I'm talking about.
Can we see this?
Can you see what?
Not like see it like right now, but like could we go back to this PowerPoint? Or is it just for you?
Oh, that's going to put it on YouTube.
That's.
Oh, it's on YouTube too. Never mind.
Is it going to be on YouTube?
Yes.
Okay.
I put every one of them on there.
My fault.
Why do y'all provoke me? Is y'all mean to do that?
Sorry.
No, that's okay. Now, How do you find the inverse function? This is how you find the inverse function. You need to write this down because you're going to see this again. How do you find the inverse function? Finding the inverse function. All right, let me show you what the inverse function is. Let's start with f of x is equal to x squared. Everybody with me?
Yeah.
We know that that looks like this.
Yeah. Inverse.
Okay, I want to find the inverse function of f of x is equal to x squared. So I'm going to do this in red. I'm going to rewrite y is equal to x squared. That's the first step. Take the f of x out because you don't need it. You're not trying to impress anybody. Change it back to the redneck way and say y is equal to x squared. Now, exchange the variables. X is equal to y what? Squared. Now solve for y.
Cancel.
What does y equal? Y is equal to the square root of x. And go ahead and put a -1 here because you've just found the inverse function of x squared, which looks like this. That's the inverse function. Now, why isn't it below the x-axis? Because you can't take the square root of a what? Negative number. So that's why you only have this part. But if you was to draw it, it would look like this. And what is the red function? A sideways version of what? The black function. That's what the inverse is. Sideways function. And if you look here.
I was thinking it was the opposite.
No, it's not the opposite. It's the sideways version or the symmetrical. Look at here. Take our handy dandy highlighter and look at this function. Look at this leg. It goes up like that, and then look at this leg. It goes like that. You see the inverse? This one's going this way, and this one's going what? That way. And they overlap right here. And they look symmetrical. This looks like this, and this looks like this, only it's going in the opposite direction. So now do it with this. They've already changed it to redneck version. So you got your y. Now what? Interchange. So x is equal to 2y squared over y squared plus what? 1. Now we need to solve for y. First of all, you got to get rid of the what? Fraction. So go ahead and get rid of the fraction. How do you get rid of the fraction? Multiply through by the what? Common denominator. Somebody listen. Jake, did you listen?
Of course.
Okay. So I'm going to multiply both sides by y squared plus 1. So now I got x times y squared plus 1 is equal to 2y what? Now I've got to get all my y's on one side and all my x on one side. Now I've got to distribute that what? That x. So xy squared plus x is equal to 2y squared. Now get the x's on one side and the y's on the other side. Well, we're going to do that. We got to get all the y's on one side. We got to move that xy over here. So x is equal to 2y squared minus xy squared. Now what? This is algebra. This is algebra 1 and algebra 2. So everybody should know what to do next.
Square root.
Nope,
You could divide X.
nope.
Oh, you combine like.
Can you-
You got to do something before, what is the opposite of the distributive law? Don't pronounce it. Factor, out, common, term. What's common?
Squared.
Now divide by 2 minus x. Y squared is equal to x over 2 minus x. Now what? Y'all said a while ago, to get y by itself, take the what? Square root. So the inverse function of this function right here, the inverse function of that, y to the negative 1, is equal to the square root of x over 2 minus x. Now, do you remember what I said about my 130 calculus? People don't suck at calculus. People suck at what? Algebra. And I guarantee you there's 2 or 3 of y'all somewhere that went, oh my God, I don't remember how to do that. Because when I asked y'all to factor out a common term, y'all just sat there. So hopefully that's knocking some cobwebs loose, because you're not going to say anything, so I don't know whether you know how to do it or not. But if you fail, it's my fault, right? And that's what they're going to go through, and we see that that's the inverse function. Okay? They didn't do it, but I did. I went through and got the inverse function. There you go, replace x with y. That's what we're doing, so I'm not gonna spend a lot of time on that. Okay, that's a circle, and we're not gonna worry about circles because you don't do many circles in business, so I'm not gonna worry about circles. I don't even think your homework has any circles in it. Okay. All right. So that is 4.1. So right now y'all should be working on 3.1, 3.2, 3.3, 3.4, 4.1. What should you be concentrating on? You should be concentrating on 3.1 and 3.2, and make sure you can use your graph with 3.4 and 4.1, your graphing calculator or your what? Your Excel spreadsheet. So you need to write that down. Focus on 3.1, 3.2, 3.4, and 4.1. Make sure you can work on your calculator. Capiche?
Posh.
All right. I'm going to just make sure, I'm just going to say everybody's here. Y'all have a good day. Make sure you X out.